Good morning, students. So, in previous class, we already discussed about the some basic approaches of the image processing, as well as we already saw some basic implementation, basic operation over the image processing through the MATLAB. Okay. And as we already discussed these things, fundamental steps of digital image processing. After that, we already discussed components of an image processing systems. Okay. Now we are going to understand some other concepts, which are the basic approaches of the images, so which helps to generate the images as well as how we have to perform the operation over the images. So some basic approaches we have to understand. So first approach, one of the major approach, that is image sampling and quantization. So image sampling and quantization, it is one of the um, major approach basically which helps to generate the digital images. So as we already discussed in our previous lectures that if we want to generate the images, then what happened, we received, or we can say sensors through the devices. There are sensors, and that sensors are received the signals, and that signals are going to be converted in the form of the digital form with the help of analog to digital converter. So under that part, digital converter, there is one major approach that is called sampling and quantization. That sampling and quantization basically helpful to generate the images, digital images. Okay, so to create the digital image, we need to convert the continuous sense data. Continuous sense data means we are talking about the signals. So that signals is going to be converted into the digital form. And for that purpose, there is two processes are required. Then first process is sampling and second one is quantization. So okay, so this is one of the example of the analog images. So that is the previous time where that when we don't have digital images, these facilities digital. Okay, so that time analog signals are going to be converted into the analog images. So and that time, and if you are talking about the analog signals, yes, that, and for that analog signals, if you want to convert that signals into the digital images or digital form, then definitely analog signals that contains volt. We have to represent the information in the form of the voltage and time. We have to represent that information in the form of the time domain so that we can calculate the discrete value, and with the help of these discrete value, then we can able to find out the calculate the digital images. So if we are talking about the basic approaches of the digital conversion of the analog to digital form, so we required two things. We have to sample the function. Okay, so as we know that we always say that that image is basically we are taking as a fxy. Fxy is the function. So xy contains what? Xy contains coordinate values. So again we have to sample the function in both coordinate values and amplitude values. So coordinate values are basically given the location, and amplitude value which gives us the intensity value. So with the help of these two things, we can convert analog signal to digital images. And the mainly if you're talking about the sampling and quantization, so if we are able to calculate the, or we can say find out the digital value, discrete value, okay, discrete value of the coordinates, then that process is called sampling. Okay, so like this in this example, uh, let's suppose a and b, from a to b one signals are transmitted, and that are basically represented in the form of the x and y direction. So if we are able to find out the coordinate values, okay, let's suppose you can take any point. Okay, so over this point, if we can calculate the x value and y value, x and y are the coordinate values. So that process basically known as a sampling. And if we are talking about the quantization, so for quantization, we have to calculate the amplitude values. Digitizing the amplitude value is called quantization. So that quantization means that we are ultimately find out the intensity value. So that intensity value, these are what, as you can see here, these are the intensity values, which basically showing their shades, colors. So if we are able or we can able to find out the values, discrete values of the amplitude, then only we can say that process basically known as the quantization. Okay. This is one of the example. In this example, what we have, the first image, basically we are taking as an input image. Over this input image, when we are going to perform sampling and quantization approach, so at that time, what we have to do, we have, according to the sampling approach, we have to find out the coordinate values. So for this input, for particular uh, input information, let's suppose this is the first input information which is taken by the sampling. So for that information, we have to calculate the coordinate values. So we can, if receive like this, we can receive the here as a coordinate value. Okay, over this coordinate value, we have to perform quantization. So through the quantization, we can calculate the intensity value. So over this position, okay, over this calculated coordinate values, we can put the quantization intensity value, which is obtained by the quantization. Okay, so this processes will be performed with the input available information, and according to that, when we completely calculated the sampling and quantization for each input information, then that information, if we are going to represent that information in the form of the image, then this will be look like this. It is not guarantee that it will give the 100% same as an input image. It may be uh, approximately same. So after that, there are many other processes, so that through that processes we can convert, we can able to obtain the original form of the image. So hope you understand about the sampling and quantization. Sampling is what? Digitizing form of the coordinate values. Quantization is what? Quantization is generate the digitizing of the amplitude value. So if we are talking about the resolution, yes, for each image, it can there have their own resolution. So if we are talking about the spatial resolution and gray level resolution, it is exactly almost same spatial resolution and gray level resolution. So spatial resolution, it is what? It is the smallest detectable detail in an image. So any smallest changes, okay, in terms of any form of the image, okay, it may be intensity value, okay, small change, any detectable change, any changes in the edges. So all information comes as a spatial resolution. And if we are talking about the gray level resolution, so any smallest detectable change in gray level. So when we are talking about only gray level, any changes, any small changes in gray level, that is called gray level resolution. So that resolution is important, and through that resolution, basically, we can able to find out the size of the image. What should be the storage criteria of to store the image. So for that purpose, we have the concept to calculate the size of the image. Okay. So let's suppose if we are going to ask that how many number of bits are required to store a digital image, then you, then you can be calculate with the help of this few operations. Like first of all, you have to find out the resolution of the image. And for that you require these things, these terminologies like m comma n. M is what? M is total number of rows of the image of the matrix. N is total number of columns. Okay, and the third one is L. L is what? L is discrete gray levels. Discrete gray levels means that how many different gray color are represented into the image for each pixel. Okay, so with the help of this we can, and this uh, gray level, how we can calculate this gray level? So for that purpose we have one another formula, that is L equal to 2 key power k. So remember this formula, L equal to 2 key power k. K is what? K is the number of bits required to represent a gray value. Okay, so if you want to store any image, so first of all you have to find out that how many number of bits uh, is utilized to represent a gray value. Gray value means intensity value, pixel value. So how many number of pixels, how many number of bits are required to represent a pixel value, and that is basically tells give us the answer of this L. So let's suppose we are taking a uh, we are taking 8 bit, 8 bit pixel value. So if we are taking 8 bit pixel value, so it means the value of k is 8. So if the value of uh, k is 8, then it should be 2 key power 8. 2 key power 8 means the output is 2 key power 8, that is 256. Okay, so it means L is equal to 256. L is what? L is discrete gray levels. Discrete gray levels means different shades of the gray level, gray image. Okay, so how many gray shades, how many number of different gray colors can be possible when the number of bits of pixels is 8? So then that time the answer is 256. Why 256? Because the pixel value, the bits which is required to store the pixel value, that is 8. So the value of k is 8. So it is 2 key power 8. So L, what the answer of two different shades of gray level is L equal to 256. And to store that information, okay, or we can say to represent that different shades of gray levels, we can utilize this range 0 to L minus 1. As I already told you that this 0 represents what? Black color. Okay, and this L minus 1, it is represents white color, and between this range we can have different shades of the image, gray color. Okay, so L is what here? 256 in case of k equal to 8. So then that time, eh, what maximum range can be possible? So we can have 0 to 255, where 0 represents black color, 255 represents white color. And for that purpose, and for if you want to store that image, okay, so we can calculate the storage area to store that image with the help of this formula: b equal to m into n into k. M is what? Number of rows. N is what? Number of columns. K is what? K is number of bits required to store the pixel value. Okay, so whatever the output come, that is the storage information in the form of the bits to store the image. Okay, so this is how we can calculate the things. Okay, and one more thing, most of the image processing concepts, when any one value is given to you, let's suppose only the value of m is given to you, or many times only the value of n is given to you. So on that case, when you have only one value, either m or either n, on that case you have to consider, you have to take the assumption that the value of m should be equal to value of n. So m equal to n, it means number of rows is should be equal to number of columns. So that assumptions we can take when only one value is given, either m value, either n value. Okay, so this point you should always remember. So this is the example where the number of storage information is given to you with the different number of bits. Okay, so as you can see here, this first column is, in first column, all the value of n is given to you. Okay, in the above one, the value of k is given to you. Okay, so k equal to 1 and n equal to 32. So if you want to calculate the storage area for that particular image, so what should be the output? So the formula is b equal to m into n into k. As you can see here, b equal to m into n into k. So in this case, n is given to you, k is given to you. So as I already told you that if m is not given, so you have to consider that m equal to n. So it means the value of m is also 32, n is 32, and k is 1. So if you are going to multiply 32 into 32 into 1, so the output will come 1024. You can use your calculator and find out the answer. Okay, similarly, if you are choosing the value k equal to 2, in case of when n equal to 32 and m equal to 32, so you got this output. Okay, so this is how we can calculate the storage area in the form of the, in the terms uh, of the bit values. Okay, now this is a now we have another approach, another basic approach, that is where we have to understand about the neighborhoods. So we have uh, three major categories of the pixel values. Okay, first of all, you have to uh, understand about the pixels. That pixels basically uh, contains in the form of the matrix. Okay, so in matrix, when you can see here, if we are taking only, if we are talking about the one pixel value, okay, where we want to perform any operation. Okay, so that first of all, that pixel is called as a central pixel, where we want to perform the operation. So we generally call that pixel as a central pixel. Okay, so for that central pixel, we have closest neighborhood pixels. Closest means just after that. Okay, so if you are talking about the just after that pixel, so if we are taking one type of the neighborhoods, like four neighborhood, so in four neighborhood we can take only this one. If the coordinate values of center pixel is x and y, so we can take four neighborhoods like this: top pixel, lower pixel, left hand side pixel, and right hand side pixel. Only closest pixel we can take like this. Okay, so then that time it is called four neighborhood pixels. And other one, we can choose four diagonal neighborhood pixels. Which, okay, so four closest diagonal neighbors we can choose, and according to the coordinate values. Okay, and another type, eight neighborhood pixels. Eight neighborhood pixels means, yes, the maximum uh, neighborhood, closest neighborhood pixels can be only eight, with the help of with the combination of four neighborhood pixels and four diagonal neighborhood pixels. So if we are combining all these two types pixels, then we can obtain eight neighborhood pixels. So this is the just neighborhood, about the neighborhood pixels. And if we have neighborhood pixels, and if we want to connect one pixel to another neighborhood pixel, then that is called as a adjacency, adjacent pixels. Okay, two pixels that are neighbors and have same gray levels, that is important, same gray levels. Okay, then they are called as a adjacent pixels. Okay, and that adjacent pixels are basically can be represent four adjacent, diagonal adjacent, eight adjacent, or m adjacent. M adjacent is what? A m Yeah, means mixed adjacency pixel. Okay, so what are these? Four adjacency pixels are called two pixels P and Q with values from V. Okay, are four adjacent if Q is the set of N4P. Okay. First of all, when two pixels are called four adjacent, when first of all, first condition that those two pixels should be lie between the V set. V is a set where some intensity values are given to you. So we can say only those pixels are adjacent when those two pixels like P and Q, both value of P and Q should be lie under this V set. V is just a set where some intensity values are given to you. So okay, so four adjacent means we have to find out two pixels value. Okay, let's suppose P and Q. If P and Q are four adjacent or not, so only if we can say if Q is the set in N4P. Okay, N4P means four neighborhood pixel. Okay. Similarly, eight adjacency, two pixels P and Q with values from V are eight adjacent if Q is the set of N8Q. Okay, let me show you with the example. Okay, this is the first one is given to you as an example as an input information. Okay, where small matrix is given to you. Okay, and first of all, the value of V should be given to you. So V is equal to 1. V equal to 1 is given to you. Okay, it means we can take only, matlab, we can say only uh, though uh, only only two pixels can be adjacent where where the value of P and Q can be 1. Okay, like if you want to say uh, we want to check this pixel and this pixel 0 and 1, are they 4 adjacent, are they 8 adjacent, are they m adjacent, yes or no? So the answer is no, it cannot be any kind of adjacent. Why? Because the value of V is given to you and the value of V is 1. So 1 can be connected only with 1. Then we can find out the adjacency. Okay. So this 1 cannot be connected with this 0 in case of the adjacency. Okay. So this 1 can be connected with this one. So this one can, if this one is connected with this one, then it is called which type of adjacency? Then that time it is called what? Four adjacency. Okay, and this if we are talking about this one and this one, then this one can be connected with this one, and again it is four adjacency. And if we are talking about this one and this one can be connected with this one, then this is what? This is eight adjacency. Oh, sorry, diagonal adjacency. It is diagonal part. Okay, so we can say it is diagonal adjacency. And if you are talking about this one to this one, then this one can be connected with this one, then this is called again diagonal adjacency. So this is how we can find out the adjacency. And if you are talking about this whole process, so this complete path, this one to one we can connect it, this one to one we can connect, this one to one we can connect, this one to one we can connect. And in this, if we are talking about the whole process, here we can see here we are following four adjacent as well as eight adjacent, diagonal adjacent, both we can consider, we are considering here. So there is a combination of four and n4p and ndp. Okay, so it means that is what? That is 8 adjacent. Okay. And if we are talking about the M adjacency, so M adjacency, what is the condition of this M adjacency? That is mixed adjacency. So two pixels P and Q of the same value are M adjacent if either There are two conditions, and one of should be followed, satisfied. P and Q are four adjacent. This is the one condition. Either this condition should be satisfied, or P and Q are diagonally adjacent, and P and Q are diagonally adjacent and do not have any common four adjacent neighbors. Which means P and Q can be diagonally adjacent, but there should not be any common four adjacent neighbors. So we can see here in emergency case, this one can be connected with this. Yes, with this is because it's following first condition N4P, 4 neighborhood pixel. This one can be connected with this. Yes, it is satisfied because of it is again followed the concept of N4P condition, 4 neighborhood concept. This one cannot be connected with this one according to the emergency condition. What second condition? Second condition is what? Do not have any common four adjacent neighbors. Okay, it means here we can see this one and this one. This one has four neighborhood neighbor. This one has also four neighborhood four neighborhood pixel value, and this one is common for this one and this one. So this one and this one cannot be connected diagonally according to the condition, but this one can be connected diagonally with this one because there is no common um, pixel value. Okay, so this is how we can show the emergency between the pixel values. Okay, so one another thing that is called path. Yes, path we can see if we are going to find out the path. Yes, this is all our this if we want to move find out the path between from one this position one to this position, then we can choose the path like this. Okay, so that path can be represented like this. Okay, so let's suppose from this one we want to move this side, then this from this one we can move here. This one we can move here, this two, and this from this two we can move here, this one. So we can choose this. These are the coordinate values from 1 3 1 3. This is 1 3 from 2 1 2 1 2. This is the 1 2 position. Then 2 2. This is the second 2 2 position. Then 3 3. This is the 3 3. So this path we can generate, connect the one pixel to the another pixel, or we can have another choice. From this one we can choose to this position 1 3 2 2 2. This is 1 3, this is 2 2, and then we can move to the 3 3. So we have another choice when we are following 8 adjacent concept. Okay, and when we are following M adjacent concept, then simply from this one to this one we can move, from this one to this two we can move, from this two to this one we can move. So this is the path information in the form of the coordinate values. Okay, students. So this is a basic overview about the pixel values, neighborhood pixel values, which basically uh, definitely we are going to utilize all these concepts when we are going to perform any operation, and when we are going to perform going to any low level image processing concepts we want to implement in MATLAB, then all these concepts are going to be utilized. Okay, students. So for today, it is much enough. And if you have any query, any doubts related to that, then please note down that your queries in our discussion class. Definitely, we are going to discuss, solve out, sort out your queries. Okay, thank you. Thank you very much.